Okay, so here we have the equation y equals 2 ln sine of 1/2 of x between pi over 3 and pi, or pi and pi over 3. And we're looking for the length of the curve, so we first have to let's find out the derivative of this, and we can find that the derivative with respect to x is 2 times 1/2 cosine 1/2 of x over sine 1/2 of x. And that happens because take the derivative of sine of 1/2 of x, you have to get the 1/2 in front, and you get cosine. And then looking at that, the 1/2 and 2 cancel out, and you're left with cosine 1/2 of x over sine 1/2 of x. Well, this just equals cotangent 1/2 of x. And then you plug this into the length equation from the integral of pi over 3 to pi, square root of 1 plus cotangent 1/2 of x squared dx. Now, a little manipulation, you realize that this squared cotangent squared 1/2 of x plus 1 is really just cosecant squared 1/2 of x. And we get this integral. And then that squared cancels out to make it even more simple, to leave it to cosecant 1/2 of x dx. And then from there we can just take a simple integral and get 2 ln absolute value of cosecant x over 2 minus cotangent x over 2 from pi over 3 to pi. And then we just start plugging it in and solving. And we get this 2 brackets ln absolute value of cosecant pi over 2 minus cotangent pi over 2 minus ln absolute value of cosecant pi over 6 minus cotangent pi over 6. And you get 2 ln of 1 minus 0 minus ln of 2 minus square root of 3. And the brackets I just used to help make it look cleaner, so I know that the 2 comes in at the end. You end up finally with negative 2 ln of 2 minus the square root of 3, because we all know that ln of 1 equals 0. And that's it.